Bert, Ernie, and Elmo. So I'm going to draw my little triangle. Bert, Ernie, Elmo. Okay. Then it says that the distance between Bert and Ernie is 10. The angle formed at Bert is 30. And the angle formed at Elmo is 105. Now, here's the thing. Some of you all were doing more than what you had to do. You have to make sure you're answering the question. And the question was, how far apart are Ernie and Elmo? This is the only side that I asked for. So if you found the distance between Bert and Elmo, you did too much. It only asks for one side. So do I have a pair? Do I have an angle side pair? So do I have an angle and an opposite side? We do. So we know that Elmo, so if I take the sine of Elmo's angle over the opposite side, and I'm going to set it equal to the sine of Bert's angle over x. When you cross multiply, you should get 10 times the sine of 30 equals x times the sine of 150. Oh, it is 105. Thank you so much. It is definitely 105, not 150. Thank you. All right, so 105. Oops, let me actually erase the whole thing. Okay. So this is what we have. So when I cross multiply this direction, I have 10 times the sine of 30. The other direction, x times the sine of 105. And then I need to divide both sides by the sine of 105. So the distance would be 10 sine 30 divided by the sine of 105. It didn't tell me where to round to, so I'm just going to the tenths place. So you should have an answer close to 5.2. And never forget units when we're talking about a word problem. All right, anyone need help or need me to re-explain that? We have our test next week, and we have a skills check this week over the law signs. All right, let's take out our notes. We're going to talk about the ambiguous case. The ambiguous case. Go to page 11. Okay, so the ambiguous case. First of all, we use the law of signs. This is the only time. Do you remember from geometry where you had to learn triangle similarity? And it was angle, side, angle, angle. Does that kind of sound familiar? All right, for law of signs, we are either going to have angle, side, so two angles in one side, or two sides in one angle. Everything we've done so far, including the bell work and everything we did yesterday, we had two angles and a side. So now we're going to look at, well, what happens if we get the bad word backwards? Okay? When that happens, it's the ambiguous case. The reason why is because we don't know how many triangles we can get. In your homework, this is 28, 32, and 34. So that's why it says, determine whether the given information will result in one triangle, two triangles, or no triangles. Okay. What does this mean? So if I know an angle, a side, and a side, I don't know if this side is long enough to hit this third side. That's when you would have no triangle. Okay, because again, we don't have a lot of information. We have this arm that's swinging, but I don't know if it's long enough to connect to the third side. So when that happens, the calculator will give you an error, which means there's no triangle. Sometimes you will get one triangle, but the tricky part is sometimes you can actually have two. Okay? So that's what we're going to talk about today, and how you can determine how many triangles you have using the law of sines. So let's get started. Again, notice that we have the bad word backwards. Example 5. I have a side, and an angle. This is ambiguous. A side, and an angle. So let's go ahead and fill it in. So I'm gonna call this ABC. Actually, I'm gonna call it ABD because I don't want to use C, because capital C and lowercase c look the same and it's confusing. So I'm gonna use ABD. All right. So we know big A is 42. I know little a is 3. And I know little b is 8. Do I have a pair? Yes. What do I have to look for first? Can I find angle D? Do you know little d? No. So what do you have to start by finding? What angle? Angle B. So let's set it up. So we're going to take the sine of 42 over 3, because again, this is my pair. That's my pair. And we're setting that equal to the sine of angle B over 8. So let's cross multiply. When we go this direction, and then we're also going to go this direction. So that's going to give me 3 times the sine of angle B equals 8 times the sine of 42. Divide both sides by 3. So that means that the sine of angle B equals 8 sine 42 over 3. All right, if you're trying to find an angle, what do you have to use to find an angle? Inverse. So that means that angle B will equal the inverse sine of 8 sine 42 over 3. Go ahead and type that in your calculator. So what does your calculator say? Domain error? You got an error? So what does that mean? What? Yeah, so that means that we have no triangle. So what that's saying is it is impossible to create a triangle that has a 42-degree angle and 2 sides that measure 8 and 3. It is not possible. So we have no triangle. Questions? So no triangle is the easy one, right? Because you get an error and you can stop there. Thank you. Let's go ahead and map out example 6. Hi.
Hello.
Thank you. Oh, she's not here.
Today?
No, I haven't seen her.
Thank you.
Okay. All right, so let's look at example 6. Again, we have the bad word. We have a side, and an angle. Let's go ahead and map it out. I'm going to use A, B, and D. Let's fill it in. Big A is 34. Little a is 2. Little b is 3. So we're going to set up the law of signs using big A and little a. So we have sine of 34 over 2 equals the sine of angle B over 3. So I got 57.012. Anybody else get that? So what that tells me is I at least have one. I could have two, but I definitely have one. So let's finish solving the first triangle. So first triangle, we know that angle B, I'm going to call it B1, is 57.012. How do I find angle D? Triangle sum. Pick up your calculators. That is going to be 180 minus 34 minus 57.012. Which would be 88.988 degrees. So what's left to find? I know big A and I know little a. I know big B and I know little b. I have the capital D. What am I missing? The small d. So let's go ahead and do that. So in order to find that, I'm going to take, this is my formula, I'm going to take the sine of A over A and set that equal to the sine of capital D over little d. So go ahead and fill in your numbers and solve it for that side. Robin, can you sit up for me, please? Thank you. So, Aaliyah, what did you get for lowercase d? Oh, okay. So you should get 3.576. Who got that? All right, so what we know is that there's definitely one triangle. Now let's figure out if there are two. This is how we start figuring out if there is a second triangle. So I'm going to say second triangle. And I'm going to put a question mark because I don't know if there is going to be a second triangle. Now, this is what we know. If there is a second triangle, that means that B1 and B2 would be equal to what? What do these angles equal? Who remembers from geometry? What do they equal? I think you said it right, but I didn't. 180. Does anybody remember what they're called? Two words. One begins with the L, second one begins with a P. Linear pair. So what that says is that anytime you have angles on a straight line, it always adds to 180. So the second triangle, we already know the given does not change. So A is still going to be 34. B2 would be 180 minus B1. So B2 would be 180 minus 57.012. So go ahead and see what you get for B2. Did you get 122.988 degrees? Who got that? So, in order for there to be a second triangle, when you add these together, A and B2, it has to be less than 180. All right, so go ahead and add those two angles together. Add A and B2 together. And you're basically trying to figure out, is it less than 180? If it is, that means we have a second triangle. So now we're going to find D2. D2. So D2 is going to be 180 minus A minus B2. So go ahead and see what you get when you take 180, subtract 34, and 122.988 degrees. Did you get 23.012? Okay. So now we have to find little d. Little d2. So to find little d2, I'm going to do the sine of angle A, 34, over little a. Set that equal to the sine of 23.012 over D2. So go ahead, cross multiply and solve that. So the ambiguous case, if you have an angle side, is straightforward. We don't have to worry about it. We know we have one triangle and one triangle only. But if you have side angle, that's different. We don't know how many triangles we have. We don't know if we even have a triangle. And that's why we have to do a lot more work when it is two sides and an angle. So cross multiply that out. So we had to solve two triangles. So we have two triangles that we had to solve. Questions? Go ahead and set up example 7. Set it up. Let's see how many triangles we have. Okay, so I'm going to do A, B, D. So we know big A is 120, little a is 250, and little b is 195. So we're going to start by finding angle B. So I'm going to take the sine of A over A, set that equal to the sine of B over B. Okay, go ahead and solve it. If you don't get an error, that means we have at least one triangle. We could have two, but we definitely have one. Did anybody else get 42.493 degrees? All right, good. So now we know two angles. So that means we have at least one triangle. In this triangle, angle A is 120. Angle B is about 42. Now we need to find angle D using triangle sum. Take your 180 and subtract 120 and subtract 42.493 to get the third angle. So you should have that angle D is 17.507. So now we need to find baby D. So I'm going to take sine of big A over A and set that equal to the sine of capital D over D. So that would be the sine of 250, the sine of 120 over 250. And that's going to equal the sine of 17.507 over baby D. So you would have D equals 250 sine 17.507 divided by the sine of 120. And type that in and see what you get. Okay. Any questions about the first triangle? We found everything in the first triangle. We know big A, big B, little b, big D, little d. Now let's see if there is a second triangle. I'm going to put a question mark because I don't know. So let's see if it's possible. If there is a second triangle, angle A is still going to be 120. B2 is a linear pair with B1. So that's going to be 180 minus 42.493. Go ahead and type that in your calculator. So I want to ask you a question. Before we continue, is this possible? Can you have a triangle? Is it possible to have a triangle where one angle is 120 degrees and the other one is about 138 degrees? Can that even happen? No, because triangle sum is 180. So this is not a possibility, okay? So there is no second triangle. We're going to cross that out. There's just one triangle, and this is what those dimensions would be.